So my name is Daniel Edgar. Nice to meet you. I'm a project manager at NGINX, and I'm focused on application security. I'm going to take you through securing your deployed applications featuring NGINX App Protect. So let's get started. So what have we done so far? Well, first, Timo and Libby deployed WordPress on NGINX Unit. James then introduced NGINX Plus, thank you, for HA load balancing and caching for performance. And it's looking great so far. However, we noticed something strange is going on. New user accounts are being created fraudulently in WordPress, and the content has been defaced. As it turns out, my website has a vulnerability that hasn't been patched, allowing hackers to exploit it. So what can I do about this? Well, we're going to introduce a web application firewall, or WAF for short, called NGINX App Protect, right into our NGINX Plus data plane. But first, we need some context. So why should we use a WAF as a security control? Well, let's be honest, web application security is difficult. It's very difficult. And a WAF is the most cost-efficient way to address web app security. Developing and maintaining comprehensive web security controls can consume a large percentage of the limited budget you have for developing the actual application and its features. In a majority of organizations, though, apps are critical to business. But at the same time, apps are the #1 single point of entry in successful data breaches. So with all that said, how are you protecting your apps? Well, NGINX App Protect is a lightweight web application security solution built around 3 priorities. 1, app-centric security designed to protect and provide security controls early on in the app dev lifecycle in order to prevent downtime and breaches. It's a high-performance, lightweight solution designed for modern applications. And 3, it's CI/CD friendly that enables security and DevOps teams to market faster at a reduced cost without any surprise delays. So from a technical perspective, though, what is it? It's a dynamic module installed on top of NGINX Plus. It's a lightweight software package. It's cloud agnostic. It's location agnostic, so I can run with consistent security policy whether or not I'm deploying on my local machine, multi-clouds, my own data center, whatever. And finally, it leverages F5's core security technology, which has a longstanding reputation for providing security efficacy. So we're going to deploy NGINX App Protect to provide protection against current and future vulnerabilities without introducing performance or process bottlenecks. So is that complicated? Well, let's have a look. We're going to get into the demo. So here's the NGINX Space WordPress site with the collection of planets. Nothing new here. However, as it stands, this application is not protected. So let's test that out. I'm going to attack the site with a cross-site scripting attack in the URL. Something blatantly obvious, but the application didn't know how to respond to it. Fortunately, I didn't have a vulnerability in that particular part of the application. Otherwise, we would have an issue, but it didn't. However, it wasn't aware of the kinds of activities that were going on at the application's attack surface. So let's go ahead and look at what it takes to enable NGINX App Protect on this WordPress application. All right, so what we're seeing now is my Visual Studio Code, my repository of everything that represents this application today. We have the WordPress site, we have the database, etc. And we have our NGINX Plus instance that we're going to extend with NGINX App Protect. And I've chosen to implement my NGINX Plus application security in a Docker container, and I'm using CentOS 7.4. So my Docker file is going to reference that base. I'm going to use my NGINX certificate and key, which is necessary to download the components that are needed to install the requisite packages. And finally, we're going to install App Protect. An important thing to highlight here is that in order to be considered a DevOps or automation-friendly tool set, we need to leverage the platform's package management tools natively, rather than introducing our own proprietary processes. So we're going to install App Protect this way. We're going to install the latest version of the signatures or attack definitions, which is also important. And you'll notice there, James modules for NJS and Prometheus are still there. And we're going to do some cleanup, and we're going to install it from the entry point.
Quick question for you. So I see you're using CentOS as a base image. Let's say I was a hardcore Debian fan and I just wanted to use like Debian Slim as a base image. Can I apt install that one yum package that you just referenced in the Docker file?
You can use, whether it's VM or Docker, or whatever, you can use Debian 9. We support 9 right now as your base image, if that's your preferred distro. Also support RHEL 7 as well as Ubuntu 18.04 LTS right now. Thank you. Good question, though.
Yep, thanks.
So we're installing it. Okay, and I've already actually started up the container earlier with the rest of our application. Now here's the configuration file that we've created earlier. And at the top, all I really need to do is reference that module. So we did that. Now we're in our load balancing configuration file that James introduced. And you might notice that I've introduced SSL, technically TLS protection for this application, as most would want to do if we're being security conscious. So you're going to see these additional entries here. But right next to that, I have a set of directives related to NGINX App Protect. So I'll start with logging first. I can define logging at a very high level context in the NGINX configuration. Obviously, the master switch is here to turn logging on. The logging format, which by default is using a name value pair, comma delimited format that we're going to use to ingest into Logstash in the elk stack later in the demo. So for this first server context, I've shifted down from port 80 and I'm redirecting to 443 secured by TLS with certificate references and appropriate ciphers chosen. And this is where the WordPress UI is hosted, and I'm going to introduce App Protect directives in this context. First of all, App Protect enablement flag for this context in the security policy file. And this JSON policy file is something I've created for the UI portion of the web application. And I'll go ahead and save this file off, and we can go look at that policy file. And here in this policy file, I can get started with as little as 4 properties in a JSON file. JSON files were chosen because it's a lot easier to author, manage, version, and push them through your CI/CD pipeline than some other verbose or proprietary formats. So these are ideally stored in your version control system instead of some proprietary store. So I specify the name of this policy, the encoding type, which is UTF-8, and in this case, I'm going to start my enforcement mode as blocking. And I'm pretty confident that I can start my enforcement mode of blocking anytime NGINX App Protect sees something that looks like an attack, because I'm introducing it very early on in my development lifecycle. So before I even write my first line of code, before I extend my application at all, I have that security policy enabled in my environment. So I know it's going to work exactly the same way during development as it does when I transition into production. So if, however, you wanted to introduce App Protect and see how it's going to behave in UAT or in production, you could specify a transparent mode, and App Protect would faithfully report everything that it would block, but it will not actually block any traffic it determines to be an attack. So these are the most basic options that I could specify in this policy file. Well, what we need to do is once a policy has been enabled, all we need to do is reload NGINX Plus, which is a non-disruptive operation. And I've done that. I'm SSH'd into this Docker image.
Hey, Daniel, in addition to the blocking functionality, is there an ability to add the incoming IP to a deny list or something along those lines?
Yes, absolutely. And those are documented, as well as many other features at docs.nginx.com App Protect that describes how to do that allow and deny list from an IP perspective, as well as some other settings. All the customization values in the policy are very well documented there, as well as the schema that you can use to validate. Good question. All right, we've reloaded NGINX from the Docker container, and I'm going to go back over to the browser then and reattempt that attack that we did earlier. And we're met with what we call the default block page. The requested URL was rejected because NGINX App Protect found it to be a threat. And so immediately it blocked it, preventing the request from going to the backend servers, as we saw in our diagram earlier. And it also presents a support ID. And this becomes important from an ops perspective. So if you ever need to do some correlation between what a user might see with the detailed security events in your security analytics system.
So is there a way to customize this page so the user wouldn't see this? Like, let's say you want to do something like, similar to if you were to shadow ban someone from a site, like they may think it actually worked when it actually didn't work.
Yeah, and that's important. And we're going to see that actually a little bit later in the demo. Thanks for the setup on that. So right now I'm going to introduce a dashboard. And it's part of the Elk stack. We make available to customers. There you can look at the various things related to how people are using or misusing your system that's protected with NGINX App Protect. In my case, I have configured App Protect to send all requests, whether the outcome is clean, meaning nothing wrong with it, alerted, which is suspicious or below that, but not severe enough to be blocked. And then there's simply blocked, which means high confidence of an attack. And this is what I attempted here earlier with that cross-site scripting tag attempt. I'm going to filter based upon that. I have my client IP as the attacker and the top violators stack chart, since I'm the only one that has access to this. In addition, at the moment, which attack signatures or patterns of malfeasance were detected by NGINX App Protect, and those roll up into what we call violations, shown on the right. So the particular violation that we're seeing here is an attack signature detected and an illegal meta character was in the value. And there's a violation of threat detected. So what did we do about it? Well, we're going to explore this particular attack. And I'm going to click on open it here up to the / request. And that was the illegal meta character and attack signature detected. So inside this log, you're going to find enough information to help you make an educated decision as to whether or not you want to continue to block these kinds of attacks or make some changes to your policy based upon your application's needs. In this particular case, I was pretty obvious I was doing something I shouldn't have when I attacked it. So I probably won't make any changes to that particular setting. But at this point, I could see the date, the time, the target port, the name of the particular policy that was involved here, the source IP address, the location, the raw messages that came in from NGINX App Protect, what App Protect did about it, and why, and how we responded to it, why we rejected it. So I know this particular user saw that block page because it was up to no good. There is also the request source in there. That was my script tag as it was encoded by the browser. More details as to why it was blocked. And most importantly, then I have that support ID. So again, I can search my dashboard to figure out, okay, why was this particular request blocked in case you need to make a tweak to the application or the policy, hopefully earlier in your development and testing lifecycle.
So I have a question about that. With the tracing you're showing here, does this easily integrate with other like open tracing standard compatible tooling so that I don't have to set up Elastic and do all the other like infrastructure pieces?
So NGINX App Protect provides 3 modes of logging: standard out, syslog over TCP, as well as local logging file. So this is really just an example implementation, but I could, if I chose to, I could use something like Telegraph with InfluxDB if I wanted to use the Grafana stack, or natively I can send the logs to my SIM. We support Splunk out of the box, we support ArcSight, but the rest is open because we've landed on these open standards for logging. It's simple to go and parse them. I can even specify a JSON format of my logging output if I wanted to. So a lot of flexibility there. So again, rather than focusing on a lot of ecosystem integrations, we're relying upon open standards such as the ones you mentioned earlier to be able to morph the logs and get them in my analytics dashboard or my security information system of choice and continue to move on rather than implementing something proprietary, excuse me. That's a good question though.
I'm curious, what is the frequency of updates to the attack signatures? And can you write your own attack signatures, whether via regex or some other proprietary way?
So we tend to publish the attack signatures, as you saw earlier in the Docker file. They're a separate package, and the intent is you consume them and you load them whenever you see fit. We release them, every few weeks, depending upon severity of what's going on out there in the field. You load them up as update the packages, reload NGINX, which again is a non-disruptive operation, and you're immediately working with the new packages. However, if there's something very specific you want to defend against, something particular to your application, we do support the ability for you to write your own attack signatures in the snort style syntax and put them right directly in that policy file, JSON. So again, so it's very close to the application and versionable as you see fit.
Excellent. Thank you so much.
All right, where were we? Now we're going to go actually over to the space UI enforcement. And I'm not really crazy about that particular block page. We talked about this a little bit. I'm not crazy about the white block screen I saw as my block page. I realized only bad actors are up to no good are going to see this, but I may want to make changes to it anyway. So fortunately, you can. The place where you customize those is in that JSON policy itself, right? So I want to go from this to something that's more appropriate. So we're going to go back into the JSON policy file. My branding folks have provided me just a big mess of HTML that I'm actually going to use as my block page. And I've customized the message inside that big block of HTML with a correlation ID. I've got a simple message that says, you know, oops, something strange has happened. And I'm embedding that support ID below right in there in the response page. So right after this, I can also decide, along with this, again, I can also decide what kind of headers to return in the response. I can control the HTTP status code as well as other caching settings when this occurs. So I'm going to save this policy file off with my modifications and reload NGINX. Okay, it's reloaded. Now we're going to attempt the same attack. And until the NGINX connections bleed off, I'm going to open this up in a new browser because the other connection has been persisted with the previous version of our security policy. And now you can see my custom block page. So again, I'm able to retain the same theme and corporate guidelines. Those are all kept in check. But I have a custom message right here in case you experience problems. Again, I have that correlation ID for being able to look into it later. So that's all well and good for applications that emit HTML markup. But earlier I mentioned NGINX App Protect is really built for modern applications. So with that, we need to recognize how developers are going to be writing their applications. Many modern applications, such as this WordPress site, use API calls to the back end. This is a JavaScript-enabled app that makes API calls to the server on the back end. So the app, unfortunately, is not going to be able to react very well when a call is made that returns HTML when it's expecting JSON, right? So I probably want to customize that App Protect response for the API call. So how do we do that? I'm going to introduce a variant to our UI policy called an API security policy. And notice some differences here. We have a response page block, but it's much, much smaller. And in this case, I want to respond with JSON because that's what the browser is expecting in response. I'm responding with an object payload that the application is expecting with just some different text, but I'm embedding that support ID in there as well. I'm also responding with a 529 service unavailable response code so my application can respond in order to provide a good user experience while providing essential security for the application. So to enable that, we need to go back to our config file. I already have that directive here in the API server context, and I'm just going to uncomment that out, save the file, and reload NGINX. Now, to demonstrate this, I'm going to go back to the application, and I'm going to toggle through the planets. At this point, I want to be able to intercept that API call to the back end, which is a known way to target vulnerabilities in the back end application, is through its API. So to do that, I'll introduce Chrome developer tools. What I'm going to do is I'm going to find the location in JavaScript where it's making that particular call to load the planet data. So next time I cycle through that, I have the ability then, through a breakpoint, to intercept it. So I'm going to go backwards on Venus in the app and look at the selected planet that's being loaded. Mars is supposed to be loaded through an API call to the back end on that port 85 API endpoint. Yes, I'm aware the planets aren't in order, but that aside, what I'm going to do is instead of just passing in planet Mars to the API, I'm going to try to overload that variable, and I'm going to append a different attack this time called a SQL Injection Attack as a parameter just to see what happens. It should be blocked by our new policy. So I'm going to override that variable, and I'm going to send the request on its way. And as you can see, that if 529 response code was returned by that API call. And if I extend this out a little bit, we'll be able to see the actual HTTP call in the network tab and see what happened. For that particular API call to Mars, you'll notice that SQL injection attack on there. And what do we get back? We get properly formatted JSON markup. So the application can understand it on response to provide, again, a good user experience that's customized for my application, but still providing protection against violations. So as you can see in our demo, we're able to add application protection to the NGINX Space WordPress site in a matter of minutes in a non-disruptive way. And I, as the developer, could be in control of that security policy. And at all times, again, making it so I can deploy my application smoothly without any unnecessary friction. So that concludes the demo portion of this segment. Are there any questions at this point?
Daniel, real quick, we have a few questions that came in during the demo from the chat, lightning round style. Will there be support for these features, the WAF, with respect to the developments to the NGINX service mesh that was discussed yesterday?
Yeah, watch that space. We're planning that right now, but because we realize that not only north-south use cases are important, egress use cases are important, as well as east-west between services. So we plan on investing in that space, and maybe we'll have something to announce for you at some point next year. Maybe.
Do you publish attack info in standard CEF format for ingesting into other SIEM tools?
So common event format related to ArcSight is one of the formats you can choose. Any customization you want to do on top of that, again, you're entirely, it used kind of a Sprint F, kind of a variable replacement scheme when specifying that log format. So you have ultimate flexibility of which variables you use in there, how much data to log, and things like that. But you are going to have that, which I believe is carried in through the ArcSight format by default.